Hi, I'm Deborah Bird with the Engineering and Technology Division.
Hello, I'm Salomon Davila from the Engineering and Technology Division.
We're working with our division to move our technology and our educational pedagogy into the 21st century to develop 21st century skills, and we're doing that through a range of innovative programs. We're working particularly on articulation with high schools and creating a number of pathways that high school students can make an effective transition into the Engineering and Technology Division.
When students come to campus, we want to make sure that they're well prepared to engage in college level work. In particular, in our division, we do much of what they call career technical education. So there's a lot of problem solving, teamwork skills, even working with many sophisticated technology, of which the students need to be prepared to manage and to undertake. So we have summer jams in which students start beginning to get acquainted with the level of thinking and activities that undertake a lot of the CTE type of industry and courses.
And the summer jams are designed to be a lot of fun. One of the things we're actively trying to promote is the idea of a cohort model where students come in together and form teams, do a lot of group or teamwork. It's project-based learning, so it's really hands-on problem solving with a lot of real-world kind of problems to solve. The classes are run very much on a need-to-know basis with technology, so that they're not specific to a particular software or a particular technology, but everything is introduced as a problem-solving tool. So technology is used as a means to an end in a larger sort of design and technology environment.
And to make sure that we're addressing the industry, we actually do certify many of our programs in here. For example, automotive technology program is certified, as well as the solar technology certification that students can get to work in the solar industry. And we're looking into even NIMS, which is a metalworking industry for, certification of working in the manufacturing realm, as well as a Society of Manufacturing Engineers, which certifies design and electronics type of work in engineering technology. So we align ourselves to these national certifications to make sure that we are addressing the objectives of industry through our programs here within the Engineering and Technology Division.
One of the great things about the programs that we're offering in the Engineering and Technology Division is that they lead to rewarding careers, and career and technical education fields are one of the fastest growing areas of employment in the country, and we're finding that students who are graduating with certificates and degrees in these fields are highly employable and are earning higher on average incomes than many people who are progressing to four-year institutions. So this is an area of growth that we really want to develop at PCC, because it's really offering an excellent career building strategy for our students. With stackable certificates, they can come in and earn a certificate in a particular area in less than a year or 2 years, go out, work in the field, and then come back and further their education. So this becomes part of a lifelong learning strategy. And the way we're developing this in a specific pilot program at the moment is the design technology pathway, and this was introduced last year. We're graduating our first students at the end of this spring, and it's using all of those project-based learning cohort models, and we're integrating it with math and English, and that's a specific strategy that has really paid off in research and is proving to be very successful here. We're finding students can go through the pathway, learn the strategies of design, which are applicable in many different disciplines, not just in the design field. They're developing technological literacy, which is highly important in any field that the students might go into. But they're also finding that their English and their math classes are integrated into these themes and concepts of design and technology. So everything is reinforced. They're learning across a number of different classes simultaneously. So that's proved very effective. And then there's a second level to the design technology pathway, which is the fabrication lab, or the Fab Lab as we call it.
And so the idea with the pathway that addresses math and English contextualization, as the students progress through certificates, we would want for them to achieve their degree, their Associate of Science degree, which is a broad field of engineering technology, which includes electronics, manufacturing, fabrication, production, and CAD design, computer design. And such that we're planning to have our first robotics class in which students design and produce the full robot from the ground up without a kit. And that's going to be the first in our division. The idea is that students progress, get their degree, associate degree, and if they would like to continue with transferring as an engineering major, the pathway allows that, where they continue with the math and general education requirements to then transfer out as an engineering major. So the idea is that it's a continuous pathway from the contextualization of English and math, making sure they're college ready, college prepared, have them transfer to be our ultimate goal, if they choose to be. Otherwise, of course, going to work and coming back to fulfill their pathway dreams is also available at any time for them to just come back in and continue with their journey. The fabrication laboratory is meant to support this whole pathway, where students will continuously be going and designing and producing operating equipment to fulfill their projects and using very high-tech equipment, which is industry accepted. And again, a lot of the design still happens here in the United States. Mass production manufacturing may not, but definitely the prototyping and the ideation is still here. And students need to be well prepared to be able to interface with this high technology to design their ideas.
So the Fab Lab includes, obviously computer labs, CAD software, but also 3D printing and laser cutting, which are becoming standard prototyping technologies in the design process. We're also using vacuum forming, casting, and also integrating the Fab Lab into our existing resources with Machine Shop. So students can start out working with small, easily fabricated prototypes and can work up to some larger scale production as they become more experienced and as they progress through the pathway. The great thing about the Fab Lab also is that it integrates students across a number of different levels in the program, and what we're seeing is that peer-to-peer learning and mentorship is a really vital part of this process, and it's part of the group kind of structure of a successful design organization. And these kinds of organizations are what we're seeing increasingly in the workplace. So the skills that students are developing through design problems and producing prototypes in a Fab Lab in a cooperative or collaborative manner is the kind of experience they're going to have when they go out to work. So we're trying to develop these 21st century skills, the ability to communicate effectively, critical thinking, problem solving, collaboration, creativity, and an ability to adapt, to change. Because ultimately the thing we're finding is that technology is moving so quickly, society and work is changing so quickly that we can't realistically anticipate what our students will be encountering in the workplace even a decade from now. So ultimately our goal is to train and to develop these skills in students to enable them to succeed whatever comes along, and to adapt and become flexible, and then remain valuable members of our society and our workforce.